Hello folks, welcome to the part 3 video of this exercise 4.2 and we are going to continue with solving the properties. So let's look over here. It's a very clear cut hint from here that you should get a minus b, b minus c, c minus a. So that gives us a very clear cut hint as to how to do it. So let's start right away. We'll consider the LHS and here right away we will start with the property. Maybe see a minus b you should get, and then you should get b minus. So you can have r1 operated as r1 minus r2 if you want. Let's check how it comes. So 1 minus 1 0, a minus b, a squared minus b squared. So we are left with 1 b, b squared, 1 c, c squared. I hope we all know that this is a minus b into a plus b. What is the advantage? It helps us to pull the a minus b out. So we are left with 0, 1, a plus b. Now our next thing is to get this b minus c. B minus c can subtract like this. So what we'll do is we'll operate r2 with r2 minus r3. What is the advantage? 1 minus 1, 0. B minus c. B squared minus c squared. Just like how we did before, we can have the b minus c coming out. A minus b times b minus c. 0 of course doesn't matter, and b minus c otherwise is component r2. So we are taking it out. So we have 0, 1, a plus b, and here we have 0, 1, b plus c, 1, c, c squared. Now either that you expand from here and try to get the remaining term, or you can try to get c minus a. What we could do is just to simplify the process, maybe we can have these operated. So that means maybe we can have r2 operated as r2 minus r1, so that the terms will become a little more smaller. So what will happen here? You have 0, 1, a plus b as it is, and 1 c, c squared as it is. See how this happens. B plus c minus a minus b. So what will happen? B will get cut, c minus a. Right? Yeah, that's about it. Okay, so we can do one thing. We think of expanding it. A minus b into b minus c. How do we go about expanding this? 0 into anything is not there, so this part we need not see. Here it is going to be minus 1 times. First part is 0 minus c minus a. Next one, a plus b times, both is 0. So this part is 0, only this is going to stay. And here also it is 0, so only this is there. Minus into minus, it's going to become plus. And c minus a. Directly we are getting a minus b, b minus c, c minus a. After we eliminate all the zeros and all that, when we eliminate, this is what we are getting, and that is our RHS, and that's how we prove the result. Same way here, all the three problems are quite identical. We can just see this and we can subtract. Here we require a minus b, we require b minus c. So let's start right away in those lines, and we are planning first to do c1 becoming c1 minus c2. So what will happen? We will have 1 minus 1 0, a minus b, a cube minus b cube, 1 b, b cube, 1 c, c cube. Now we all know that this factorizes as a minus b times a squared plus ab plus b squared. So that is going to be our mode. We can take the a minus b common. So what remains here? 0, 1, a squared plus ab plus b squared, 1b, b cube. No, we will do an operation. B minus c we require. So we will c2 becoming c2 minus c3. So 1 minus 1 can become 0. Then b minus c will be there, and b cube minus c cube. 1 c, c cube will remain as it is. B minus c, same way you can pull out. So you have a minus b, b minus c, 0, 1, a squared plus ab plus b squared, 0, 1, b squared plus bc plus c squared, 1 c, c cube. Right? So many terms are there. Then we also require a c minus a. We require a c minus a. You could have these as we did in the previous. You could have this arranged, or you could have these two terms arranged whatever way, or probably you could have whatever. So we could have maybe c1 and c2, just so that we can have it simplified. So c1 becoming maybe c1 minus c2. This step. what will happen? Already we have a minus b and b minus c out. So what will happen? c1 minus c2 0, 0, and we have all these terms subtracted. You have a squared, let's do it outside. So a squared plus ab plus b squared minus b squared minus bc minus c squared. So you have b squared cut. Then you have a squared minus c squared and ab minus bc. This could be a minus c into a plus c, and this could be b times a minus c. Overall, a minus c will be out. So here the first bracket a plus c, second bracket b. So what is left here? A minus c times a plus b plus c after all the simplification. And then you have 0, 1, b squared plus bc plus c squared, 1 c c. Okay, now let's expand the bracket. A minus b is there, b minus c is there. Can't expand, last term only this will be the surviving term, and that's how we get it. Minus is there, yes. There will be a minus c minus a. That's how you'll get the remaining. That when you take it inside the bracket, because you're doing, like this, and then this minus this, like that minus comes up, and minus of a minus c, c minus a. So that is the RHS, and this is the solvent. Exactly same lines we have this problem. Same x minus y equal to and all. So let's start right away. Consider LHS. And the very first operation is going to be R1 becoming R1 minus R2. So what is happening? R1 minus R2, first value x minus y, x squared minus y squared, yz minus zx. So y squared, zx, z squared, xy. Let's take the x minus y common. So what are we left with? 1 x plus y as we did before. And here see, it is, if you take the z common, z times y minus x. X minus y has got common. So that will leave a minus z. Okay, this is as good as saying minus z times x minus y. If you open up, it will come out right. It's just a mathematical general. So minus z is right. Here what is happening? Now what do we do next? In this we require y minus z, so we will do R2 becoming R2 minus R2. So what will come? Y minus z, y squared minus z squared, and z x minus xy, like what we did before. Z squared xy. So we are having x minus y and y minus z. So we have 1 x plus y minus z. Like before, we have taken it out. So 1 is there, y plus z is there, and minus x is there. Z is there, z square is there, xy is there. Q requires z minus x. So either like before we do, or z minus x you can get from here if we add it, or if you subtract it. Yeah, we can do that. We'll do R1 becoming R1 minus R2, and let's see what happens. X minus y times y minus z. This is becoming 0, 1 minus 1, minus y minus z. So y is called x minus z, minus z plus x, so x minus z. 1 y plus z minus x, z squared xy. So take the x minus z out. So what happens? You are left with this 0, 1, 1, and 1 y plus z minus x, z squared xy. Now let's expand. X minus y times y minus z times x minus z. Let's expand. First we will not get because it's 0, then it's with minus 1. Let's see what happens. It is xy minus xz. Why it is xy here? Okay. And I just have to check. This is like this. I've got xy, and then here it is minus x, and here it is z. Yeah. So xy minus xz. Then we have this on 3 plus 1. I have got z squared minus zy minus z squared. So let's check this. X minus y, y minus z, x minus z. Let's open all the brackets and see what is coming. Minus xy plus xz plus z squared minus zy and minus z squared. The plus square y is plus and minus is there cancelling each other. And what do we require here? Plus how this one paper to say x minus z squared. Oh yeah, that minus can be compensated. I don't know how it is this. Yes, because here it is xy minus of minus xz plus xz. Yeah, because minus with the formula and the minus over here, it is plus xz. So like that we will get minus xy minus xz and every minus. That minus will come out here, will compensate with this and make it z minus x. So x minus y, y minus z, minus from here coming out, making it z minus x, and left with xy plus xz plus x. And that is our RHS. That's how we prove the result. Right. So that's about this. So with this we wind up this video. With more problems, we're coming in the next video. Thank you.